Hey everybody, in this video I'm going to show you how to find the area between curves, or the area of the region between curves, and this is something you go over in Calc 1. So just a brief overview. So let's say we have two functions, and the area, we're finding the area of this shaded region, is you're going to do the integral from a to b, and you're going to subtract the function on top by the function on the bottom. As you see right here, f of x is the function that's on top, and g of x is the one on the bottom. And you're going to subtract those two, and then you integrate. So let's just take a look at an example right here. We have a parabola, x squared, and then just a straight line, x plus 2. And so the first thing we want to do, they didn't give us the interval that we're in, so we're going to go ahead and find that. So you set them equal to each other. X squared is equal to x plus 2, and then obviously you're going to bring over the x plus 2 to this side, so then you get x squared minus x minus 2, because we subtracted them, is equal to 0. And now we could factor these out, and then you're going to get x minus 2 and then x plus 1 is equal to 0. So then the two values we have is x equal to 2 and x is equal to -1, and that's where the functions intersect, and ultimately that's the interval that we're going to be taking a look at. So we have here from -1 to 2. It's a little exaggerated, by the way, but anyways, so now we could set up our integral. We have the definite integral from -1 to 2, and then inside right here we're gonna have the function that's on top. So notice that it's not always f of x minus g of x. It could be g of x minus f of x. It's just a matter of which function's on top. So now the function on top is the g of x in this case, which is x plus 2, and then we're going to subtract it by the function on the bottom, which is x squared. Okay, and now we're gonna go ahead and integrate. So we have the definite integral from -1 to 2, and then inside the integral of x would be the power here that's raised to plus 1, and then over that, so it's x squared over 2. Integral of 2 is 2x. And then, we ran out of space. Alright, and then the integral of x squared is x cubed over 3. So that's minus x cubed over 3. Alright, and now, this shouldn't be the integral. It should be, we're going from, we're going from, because you put the integral sign when you're about to take the integral, but here we already took it, and we just want to note that we're going from -1 to 2. Okay, so we're going to substitute 2 in for x, and then we subtract it by when we substitute for -1. So now put in 2, and we're going to get, that's 4 over 2, that's 2 squared is 4 over 2, that's 2 plus 4 minus 8 over 3. Move here, and now we're going to subtract it by what we get when we substitute in -1. So minus, and you put in -1, you get a half. Running out of space here. Half, and then substitute -1 here, so we get -2. And then -1 cubed is -1 over 3, and then minus here, so that's plus 1 over 3. And now we could go ahead and add everything, and I'm just going to continue right here on top. So 2 plus 4 is 6 minus 8 over 3. That's 18 over 3 minus 8 over 3. And that is 10 over 3 minus, so we got 10 over 3 from this right here. And then minus what we're going to get from here. So that's a half minus 2. That's negative 1.5. Or in other words, -3 over 2. Okay, so -3 over 2 plus 1 over 3. And then, okay, we're going to get the common denominator. So that would be And the common denominator would be 6. So that would be negative 3 times 3, which is negative 9 over 6, plus 2 over 6. That would be negative 7 over 6. That's what we got from here. And finally, we're going to subtract 10 over 3 minus negative 7 over 6, which is, I'm just going to continue on the top. So that's 10 over, now it's 10 over 3 plus 7 over 6, because it was minus negative, plus 7 over 6, common denominator, this would be a 6, this would be a 20. So that's your final answer would be 27 over 6.